Today we are going to introduce Pandas. It is a package in Python used for data manipulation. It is extremely popular, arguably the most well-known and widely used data processing package. Our main content today will be demonstrated in a notebook, but the video introduction will be done through slides. The dataset we're going to use is the Airbnb dataset, which you can find online. On these slides, you can see the logo of Pandas and the description that you can find on the official website, which says Pandas is a fast, powerful, flexible, and easy to use open source data analysis manipulation tool built on top of Python programming language. So this is the primary accurate description of what Pandas is. The name of Pandas comes from the words Python and data analysis, something like that, and the combination of these terms to make the words Pandas. This image is from the official website of Jupyter Lab, one of the most popular notebook or developed environment for data scientists. You can see in the screenshot, or this screenshot is taken from the official website of Jupyter Lab. You can see in the screenshot, the Pandas is included in the middle of this screenshot, which demonstrates the popularity and how representative it is. Another reason I choose this image is so that you can quickly see the primary object used in Pandas. It is the thing that looks kind of like a Excel or spreadsheet in the middle of the screenshot. This object is referred to the data frame. So you can see in a data frame, it has a lot of different columns. Each column is referred to a data type in Pandas, which we call it a series. So the two main objects in Pandas are the series and the data frame. A series is essentially a one-dimensional NumPy array with a named index, and the data frame is a collection of columns, and every column is a series. Each series can have different data type, and they share the same index. So this object, the thing looks like a spreadsheet or like a table, is called data frame. In a way, it is very similar to a NumPy array with some differences. So first of all is that every column and every row are labeled. So each column and each row has its own name. And another difference is that each column in a data frame can have its own independent, different data type. Whereas in NumPy array, the entire array must have one uniform data type. Additionally, data frame is primarily just has two dimensions. Unlike a NumPy array, you can have an arbitrary number of dimensions. And typically, we don't want NumPy array to have a D type of an object because the primary usage for NumPy is for efficiency. So we rather take the NumPy array. Typically, we use a NumPy array with a D type of an integer or a floating number, which can lead to a more efficient computations and access like read and write. However, in Pandas, it is not uncommon that we are using a object as a Python object as the D type of a column, or maybe even for the entire data frame. If you are new to Pandas, I think the best learning material is the user guide available on the official website. It contains a lot of usable content, a lot of materials, especially the first section, which is called the 10 minutes to Pandas. So you can see this one, 10 minutes to Pandas, which is especially suitable for beginner. Although it says 10 minutes, running through everything will take much longer. In the past, I enjoy using this guide to introduce Pandas, but going through it step by step often takes a considerable amount of time. The 10 minutes to Pandas guide covers most of major concepts in Pandas, providing a rich overview. The later chapters dive deeper in the specific concept corresponded. So if you want a systematic way to learn Pandas, I recommend practicing through this user guide. Maybe start with the 10 minutes guide first, and then for each topics you are interested in, you can look through into the different sections. However, just following the user guide alone can feel a bit of boring or tedious because it lists and explains many different concepts one by one. When you don't yet know the advantage or how useful or what the pandas is, or you don't even know what you can accomplish with the pandas, then you just simply reading through this guide might feel like kind of like reading a dictionary. There are just a lot of content, but they are not relevant to you. To be fair, this guide writes in a very good style, so it should be more interesting and more engaging than a dictionary. I was just a little bit exaggerated, but still, it is still kind of like reading a textbook. So that's why I hope that you should gain some experience before you're diving into the guide. You should get some experience about the pandas and have some sense of what it is, what it can be, what you can accomplish with the pandas before you dive into this guide. So in this way, reading it will feel more like browsing a catalog for tools or for like do a shopping. It is more useful for you and it is more fun. Next, we will work with a notebook and focus on solving specific problems instead of simply acquiring knowledge. This will not only make it more engaging, but also ensure that regardless of your experience level with pandas, maybe you already know something about pandas, or maybe you are just a very beginner. No matter the level of your experience with pandas, by focusing on solving problems, you will find something valuable in this process. Over the past several years of teaching, we have accumulated several examples of these hands-on lab notebooks. This year, we will use Airbnb dataset, which contains data from rental listing and information from the platform that offers homestay in the Airbnb website. The dataset includes information like price, reviews, location, as well as several other informations in different tables. This dataset will be the primary example used in this video. Last year, we were working with the KKBox dataset. The KKBox is a famous music streaming provider in Taiwan. This dataset is also quite interesting. The dataset has been anonymized, so the risk of the price issue is significantly lower, and the data is available on Kaggle. After registering the Kaggle, you can access and download it and play with it. In our previous notebook, we demonstrate various different techniques for data cleaning and how to explore the data. And finally, we do some prediction in using sort of algorithm or machine learning techniques so that we can solving a problem that is related to recommendation system. So I still recommend that if you have done with the first notebook, maybe you can try to explore the several notebooks that is developed in the last year with the KKBox dataset. For the beginner tutorial, in this class, in the past, we used a dataset that provided by the Ministry of Education of Taiwan about the number of freshman students at university, or like the number of students for each years, and for university and graduate school. The dataset came from an open government data portal, and we use it because it was more relevant to the students, as most of you are either a university student or a graduate or studying a graduate school. So I assume that you might be interested in how many students or the ratio of the different type of students that is around your age. In this notebook, we explore the difference of the number of students and the gender ratios, and we group by it by different department and schools. So we can see and ask some questions like which school has the most new students or has the most high or low gender ratio. Another example, which is the last one in this list, is involving using the data from ETC, that is the paying, the toll system in Taiwan used in highway. These notebooks were developed from around like 2015 or maybe 2016. We use this data in various workshops and explore things like driving patterns, like how many cars are speeding, what is the traffic balance at different hours of the day, which time has the most traffic at which location. So at the end of this series of workshop, we develop some animations so that we can visualize the flow of vehicles throughout the days on a map of Taiwan, showing the movement of cars and the traffic data. So you can actually see that from the location, geographic locations data from the dataset, we can actually draw the vehicle flow accurately on the highway of the Taiwan map, on the Taiwan map. There are many types of problems you can analyze using Pandas and Python, and there are a lot of different interesting datasets available. However, today we will be focusing on the Airbnb dataset. The Airbnb dataset we are using comes from a website called the Inside Airbnb. It is a platform where you can find the URL when you receive the slides, or you can click on the link and in a slide or in our class webpage. You can even just simply search for Airbnb dataset. Then most likely you will find the URL of this website. The data on this site is licensed under Creative Commons 4.0 and includes datasets from several countries, as it says right at the beginning, near the top of this website. It says that it includes data from countries like Australia, Canada, France. In fact, it also includes data from Taiwan. It just didn't list on this description of the dataset on the official webpage. But anyway, we can find the dataset from Taiwan, and we're working specifically with the data from Taipei. Here is the part that lists the dataset corresponding to Taiwan and Taipei. So you can obtain and by browsing the page to this section. The data was collected on June 30, 2024 based on the website's description. The dataset was primarily scraped from Airbnb using a web crawler. It contains many different files. As you can see that most of them are in CSV format, except for the last one that is in GeoJSON format. Some of the some of the CSV files presumably to be larger, significantly larger than the others, so they are compressed in gzip format. And the following three are summaries CSV for summary informations. But we are going to use the files that was compressed using gzip primarily. That is the first three files. These three files represents the listing information, which is the first one. Room details also is in the listing, and the second one, calendar, is primarily providing information of the availability of a room of each listing items, and for each calendar date. The review CSV files contains the things related to reviews. We are not going to explore it much, but we will load this CSV in a notebook to do some basic exploration, like seeing the shape or dtype of this notebook. We'll do a lot of things for the first CSV listings and for the second one, calendar. So let's go to the notebook. This is the screenshot of the notebook. You can find the link at the previous slides to this notebook and other notebooks that we developed in previous years. So this is the beginning of that notebook. And you can see at the beginning, we list the dataset that we are going to use. So this is the first cell that is really running something. So first, we download the dataset. We're using the urllib request function to download it, so that we don't need to depend on third-party libraries. Although I think it is still worth to install a libraries like requests or something similar or something equivalent. But to make things simpler, we simply use the standard library to download the file. We also use some other modules in the standard library like the pathlib, the gzip. It's very convenient that Python comes with gzip in standard library, so that we can actually decompress the files without using extra tools. We can do this all alone in Python. So this one is just to download the data sets. So it only took me about like 10 seconds to download this file. And because I'm using Windows, you can see that the path name show the end of this output contains something says Windows path. But anyway, it just says that we download all these files in a subdirectory Airbnb data that I was just created by using the cell we just shown in last slide. So these three CSV files are the data that we are going to use. In order to do data analysis or manipulation using Pandas, first we have to read the data. In Pandas, we use pd.read something to read data. In this case, because it is a CSV file, so I use pd.readCSV. While in Python's standard library, it has a module that can and a function that can read CSV files. This function provided in Pandas is much more convenient to use. It provides a lot of different parameters so that you can change the behavior of reading CSV files to help you to overcome potential issues when you read a CSV file. CSV file is notably that format that with many variations. Microsoft has its standard of CSV file, which is kind of good because it is a standard, but there are a lot of different flavor or variations of CSV files. You cannot, when you get some data, then nothing guarantee you get a CSV file that is in maybe say Microsoft standard or in other standard. So every time you are using CSV files, you should be very careful and expecting that you might want to add some options or parameters to read the data in a correct format. Because CSV is sort of like a spreadsheet, so a lot of people may arbitrarily add some text description at the beginning of the CSV file or maybe in the middle of the CSV file, because it's sort of like a human readable format. So they don't actually thinking about for a programmer to write a program to load it. So that's why CSV is very difficult CSV is a format that is very difficult to handle. So sometimes there are some other issues like inconsistent data type in a column, or maybe especially when we work with CJK encoding, they might have some encoding issues. However, because we are working with the Airbnb dataset, I think it is more specifically consider the use of this one is for like data analysis, machine learning. So it seems okay that we can just read the CSV without any other extra parameters. But we will find that it still has some issues. We'll encounter it later. Pandas support a lot of different file formats. So there are also like a read Parquet, read Excel. It actually supports Excel files but requires you to install some extra library dependency. Okay, so let's just, because we are just at the very beginning, so let's just read this line through. So the first line imports the pandas, which we usually shorten it as the PD, kind of like the NumPy, so it is also a common convention. In the second line, we use readCV function as we mentioned before to load the data. One thing I want to talk about is the variable name. I'm calling it the listing, but I personally I like to add a suffix like underscore df, or maybe a prefix of df to the variable name. which helps to differentiate data frame from other types of data. So sometimes some people are kind of against it because the argument is that in modern day, the IDE are very advanced. There's no need to annotate the type in the variable names. You should just give a type hint and let the IDE to do that. But the thing is, when we are using Pandas, very often we are going to convert a Pandas data frame or series to other types, which you will see in the notebook. So a lot of time you may have a variable called the listings, and you convert these variables into another format. So you will have a lot of variables that is exactly contains the information of like this one, in this case the listing, but maybe it is a dictionary, or maybe it is a list, or maybe it is a NumPy array. In Pandas, it is very, very common that we convert one type to the data frame type to another type. So instead of like sharing the variable name like listings to the data frame and to other like a dictionary or maybe a list or other data type, and I prefer to have them with a different name. So it makes sense that we simply has a suffix to denote the data type. It is not primarily for the functionality like help us to know the data type of this variable. It's just that it is easy way to naming this variable, but it also kind of still faster than we move the mouse or do other things to find out what the type it is. Because in Python, it's unlike the Rust language, it rarely the IDE rarely simply generates the type at the end of each variable. One reason that we want to convert this data frame into another format is I'm just giving you one scenario why we do that. One reason is that it is not recommended to add row by row into a data frame. Although it is possible to do that, to add rows one by one into a data frame, it is not very efficient and is not recommended. So instead, it is a more common pattern to collect data in a list or maybe in a dictionary first, and then convert into a data frame. So that's why we convert the data frame to another data type or the other way around. But anyway, I'm not using this convention right here. I'm just calling it a listing. In Jupyter Notebook, when you put the listing data frame at the end of a cell, it will automatically display it. Since the data frame is quite large, so it may show too many rows or unnecessary items. So I'm using a head so that we only show the first 10 rows, which sort of making the output more clean or manageable. The display of the data frame sort of resemble to a spreadsheet or Excel spreadsheet. You will also notice that for column, because there are too many columns, so you will see these 3 dots right here because it's just too many. It doesn't want it just overflow your web page, so it skip a lot of columns. It just gives you a few first few columns and the last few columns. The same thing will happen to the rows if we didn't use the head, the dot head method. If we list all the rows, the default behavior is that it will skip the most of the rows and just showing first few rows and the last few rows. So how do we export or fill a large data frame? So one very convenient way to fill these contents in the data frame is by using tools. A lot of tools has developed for data frame. In Jupyter Notebook, Visual Studio Code, and maybe other IDEs, there are many tools available for filling data frames. Since Pandas, this is because Pandas is extremely popular in the Python ecosystem. So it is a very common demand to find a way to inspect data frames data. So for example, in Visual Studio Code, I've installed a very popular plugin called the Data Runner. You can see it right here. When the plugin detects that the final output in a cell is a data frame, like in this case, the listing dot head, so just the 10 rows of this listing, you can see this button right here. If you click into this button, you will see an interactive table that you can kind of like Excel, and you can export the data frame. So this is the page for the plugin, the Data Wrangler plugin, which is developed by Microsoft. In general, I kind of feel more comfortable when I install a plugin from Microsoft because Visual Studio Code itself is a product from Microsoft. So it's more kind of like when a plugin is labeled provided, developed by Microsoft, it's sort of like the part of the original system. But there are other plugins which serve the similar goal of data. It's just I choose this one. So this is animation shows how to demonstrate how the data wrangler work. It shows how you can interactively use data wrangler to explore data. You can choose different columns to view, to sort based on specific column, to see detailed information from each column, and apply various filters to the data. Another way to activate data wrangler is from the top bar in the Visual Studio Code. This is when you opening a Jupyter notebook, it will have something like here. You can see that in the Jupyter notebook in Visual Studio, when you open a Jupyter notebook in a Visual Studio, it will have a variable inspector. You can also use this variable inspector and select the variables that correspond to a data frame. It will also inspect the variables using data wrangler. If you are not using Visual Studio Code but still working with Jupyter Notebook or maybe Jupyter Lab, there are also various plugins or tools available for this environment to help you to inspect data frames. Some of them are also work with the Visual Studio Code or even in the interactive mode, not just the Jupyter Notebook mode. One such tool is called the iTable, which we are showing on the slide. You just need to import it and it will enhance the display of your data frame with additional features like filtering, selecting rows or columns to view or sort it. It also allows you to interactively manipulate the data frame display by using Python code. I didn't use it a lot. Maybe I tried something like this one or others once or twice, but most of the time I'm just like I showed you before. Personally, I use Visual Studio Code and use the data wrangler more often than this one. But there do exist a lot of tools in Jupyter Notebook. You can choose some tools that is more suitable for you. Here is another tool that you can look. This is called the IPY data grid. It presents the table in more colorful and visual way, making it a very useful tool for inspecting data. You can see that the appearance is more aesthetically pleasing and provide a different way to interact with your data frame. I think it is pretty good tools when you, at least it is a very good tool when you do the presentations. Okay, in addition to filling the data frame, you can also see how many rows or columns there at the bottom when you just print out using just the old-fashioned print out the data frame. You are going not only just the content, you can also find out how many rows or columns the data frame has. It is similar to the shape that we were doing when we working with a NumPy array. So in this case, because we used the head 10, so we saw 10 rows. So here we have 10 rows, but you can also see that there are 75 columns in total. This is quite a large number of columns, at least for a human to read the data. As you may recall that when we talk about NumPy, I kind of emphasize that when you get a NumPy array, the two things that you need to check first is the shape and the d-type. So this one is the shape. So also we will also want to check the d-type as well. So first of all, for the shape, you can use similar method like a dot shape as you will do in NumPy and see the full shape. In this case, you can see that the full table of this listing has 5,610 rows and 75 columns. To show a d-type, here I first import the Ridge, which is a tool used to help enhance the printed output with colors. It makes inspecting objects a bit more colorful and easier to read. However, in this case, for inspecting the d-types of the data frame listings. The rich print does not add much value since it just shows the number of the columns, like 75 here in colors. But we can still see some information in this output. So first of all, we can observe that the ID has a 64-bit integer D type. And we can also see that the refuse per month has a 64-bit floating number. The interesting part is that the listing URL has an object D type, and so as the last grab and the source. In Pandas, an object is technically represent any Python object, but a lot of time it is just used for string, especially when we load the CSV file, because CSV doesn't have much different types. In many cases, object D type is good enough. We didn't bother to convert these columns explicitly to other types. But that being said, Pandas do have a string-specific type, which called the string itself. And you can actually convert a column of object to a string if it is actually a string. However, just as we mentioned before, most of the time we don't bother to convert. We just keep it as is, the D type object. It is good enough for most of the task. We will touch on some other frameworks later, some modern and alternative data framework later in this video. Most of them are more efficient than Pandas. So the D type, the explicit or more accurate D type is more important in that scenario. One challenge we face here is that the output is skipped, so we cannot see all the column, all the D types of every column. So how do we deal with this situation? One way to do that is we can use this Pandas function to set it the display, to let the Pandas to display more columns or more rows. So in this case, by setting this one, it will show all the columns or all the rows up to 100. If you need more, you just put a larger number right here. Another approach is to convert the data frame to a dictionary, which doesn't have the same display limitation. Using this method, along with the rich print function mentioned earlier, we can print everything in a nicely formatted way. This would allow us to see all the columns and their data types. So here's what you see. The first column is ID, it is integer, okay? And the listing URL is an object, so no surprise, it is a string. And the script ID is an integer, and the last script is an object. From the name, it seems like a date time or timestamp, and the source and the name are all in an object format, so they probably are just some string. And we also have description and neighborhood overview and picture URL. It seems to us that a lot of things that is not necessary for us. Things like listing URL or picture URL are just some URL or script ID. They don't seem to be very useful for us because we are not going to download these pictures. So probably are not going to use them. So to identify which column is useful and which column is not useful for us is very important because we have a lot of columns. To select the useful column is a text to help you to understand and to navigate, to explore this data frame more easier. And the next few columns are related to host or the properties of the property owner. The dataset contains the host ID, the profile page URL, the name, and some additional information. We can keep some of these details, but others might be unnecessary, like the URL, or we probably don't, maybe at the beginning we don't care about the response time or maybe response rate. There's also a host photo column, a host photo URL, like the picture here. We probably don't need this one because it's just a URL. Unless we are going to download the picture, which we are not going to do. This URL doesn't make more sense to us. So we can, although there are a lot of columns, we already find many of them, we probably can just simply discard them. The next part of these columns contains some geographic information, such as latitude and longitude, as well as text-based description. of this neighborhood or some other specification of the rooms, like the how many bedrooms or how many beds or how many accommodates, things like that. And one important column that we see here is the price. So we are definitely very interested in analysis the price of the rooms in this listing. And also we see the latitude and longitude. We may also analyze this geographic location, and maybe we can find out is there any relation between the location and the price. So maybe we can visualize the relation between the geographic locations and the price later in this notebook. And even further in the dataset, you can see that there are some minimum nights, maximum nights, and calendar update, and available 30, available 60. In fact, these availability things are related to the calendar, and this seems to be a summary of the data in the calendar. So this field may be useful, so we can do the cross-check between this listings data frame and the calendar data frame. But for the sake, we are not going to use it in this video. So these are simply easier to discard. I mean, pretty safe to discard. We are still interested. We are going to be interested in the availability of the rooms. It's just we are going to use information taken from the calendar CSV, not use these columns. Let's go even further. So in this section, mostly related to some of the reviews. So we definitely see some columns related to the reviews. I think reviews are also interesting. So we can explore things like whether they are, how many of them are like 5-star ratings, how many rooms has 5-star ratings, and how many have lower ratings. I think that's kind of interesting. So we might want to keep these columns. Additionally, we could explore the relation between price and the review score. The price is always one of the most interesting attributes of things. So for example, we can ask something like, do more expensive properties receive more polarized reviews? Or maybe if it is more expensive, then it receives a higher reviews, maybe, or maybe even lower reviews. We can do some research on this. While these are not the questions we are going to dive in today, but you can see that Pandas, or when you get a data, these are definitely some of the questions we are going to be interested, or at least we know this kind of question might be interesting to some people. So in the future, you can use Pandas to explore this kind of questions and examples. I hope in the rest of the video, we can give you a good foundation and tools to do further analysis. Because the D types are pretty useful and important, so I actually has a variable called the listing D types to store the D types in this variable. And because I make a variables right here, so we can use the data wrangler to explore it. And even better, I move the data wrangler to the side panel right here, so that I can constantly check the D type of each field and have an idea what it is. In this page, we are showing the code from Pandas, which is another data frame library, and it is more modern. It is written in Rust, and it is pretty fast. As you can see that because it is written in Rust, so the data type is very important. So although it is mostly considered as a sort of compatible to or replacement to the Pandas, they still have a lot of differences. So one difference is here. When we read the CSV here and see a D type, the D type itself is sort of more like a list than a dictionary. And you can see that the string columns actually has a D type called string. After you have more familiar with Pandas and need to deal with more data and do a lot of work in data analysis, I think there's time comes that you will need more tools. You will have a demand for more advanced tools that can handle a larger data or faster data, like the Pandas right here. And you are going to use a lot of different frameworks. So the little details matters because although they are mostly the same, these little details will block your ways if you are not be careful and familiar with that. So let's also check the D types and the shapes of other CSV files. So we do the same. We load the calendar. So read the CSV right here, and we load the reviews CSV and show their shapes and their D types. So first, it is a calendar. It has more than 2 million rows, so it has a lot of rows, but it only has 7 columns. So let's check the columns of the calendar. You can see that it has a date and the price and whether it is available. We assume this means whether it is available corresponding to this date. And also it has an interesting field called the listing ID. It looks very likely this one is referred to the ID field to the listing in the listings dataset, data frame. So this whole record might be related to the rows in the listing data frame that has the same ID. So just recall that in the listing, we have a column that is an ID. The similar thing happened to the reviews. It also has a listing ID. So it makes sense that every review is corresponding to a room or a house that is listed in the Airbnb. So earlier we discussed how to list and inspect data types and the shapes. This is often one of the first steps when we're working with NumPy, and as well as when we work with Pandas to inspect the shape and the data type and to explore the contents of the things contents in an array or in a data frame. So once you have this understanding, we are going to do the next step with our data frame. The next step is focusing on asking questions. Once you have a data frame, your goal is to ask questions about the data. Everything you do with data frame is around some questions. Every option you do is to help you to answer some questions. The operations and the functions provided by Pandas are all designed to help you to answer the question that you are interested in with this data frame. If there is no question available, there's no question that seems to be interesting to you, then Pandas won't be very useful to you. So the good news is that you will always come up with questions. You can always have some fundamental or common questions and some of your personal special questions. You will always come up with questions. A lot of questions are very natural outcome when working with data. And once you start to ask one question, it will lead to more. Just one lead to another, and you got a tons of different questions. The more questions you have, the more you will going to familiar yourself with the data, and you will have a better control over the data. So in the following examples, we'll discuss some common questions that arise when we work with data. These aren't an exhaustive list or complete list, but they are a good starting point. So often one question will lead to another, just remember that. So having some question at hand is very important, and it is a good start. So the first category of questions, I call them no surprise. I want to ensure that there's no surprise or anomalies or unexpected things happens in the data. So this process is also known as data cleaning. We want to make sure that everything in the dataset is within expected range, or there's not too large, too small values. There's no missing values. There's no extreme or unrealistic numbers. There's no wrong D types things, or maybe this should be an integer, but the number is a floating number, or it should be an even number, but you got something like odd number, or these two columns should be like have some certain relationship, but the condition does not satisfy things of this. So if we are going to check the data more thoroughly to make sure there's no surprise or unexpected things, it will make your data analysis more smoothly without. So if you have a mistake at the beginning, maybe it will ruin all the following works. Another way to get information is through basic statistical data. The most common example, including the mean, standard deviation, median, and the various percentile, such as the quantiles. Additionally, you may want to know if there are a limited number of distinct values in a column. Are there infinite different distinct values in a column, or they are just finite? If it is finite, how many? So for example, even though a column might consist integer or string, the string might represent like a few categories, like gender, educational background. So it is not just any string. It can just have like 5 or 10 different categories, or maybe just 2 categories, or maybe they are not string, they are integers, but they are like 1, 2, 3, 4, like represent different categories. So even though it is an integer, we might want to know, okay, what is the meaning of this integer? Is just a general number, or it is a category? Another important question is whether the distribution of these numbers are sort of even distributed, or maybe they are skewed, distributed unbalanced. These are just some basic statistical questions we often seek to answer. Okay, the above is just some basic questions, but as you explore further, one question will often lead to another. By using your curiosity to seek answer, you'll be able to explore and learn about this data frame effectively. This is, in my opinion, the most efficient way to work with data. So in the future, you may continue working in this field. If you approach it with this mindset, fueled yourself by curiosity and the desire for answer, whether it's out of stubbornness or something else, it will help you to engage and focus. So even if the task is very challenging, you are still going to have enough motivation to enjoy the challenge. Next, we will look at the content of the data frame. For now, we are focused on the listings data frame. First, we want to filter out some unnecessary or irrelevant columns, because, for example, like a URL, all of these URLs are not very useful for us. And also, since like ID seems to be important, but the ID is just a very long, you can see that the ID is just a very long number. So maybe we want to move it to somewhere near the end, because we should put something more important like a name and the readable things at beginning. ID is important, but it is not readable. The similar things apply to the host ID, because host ID is also just a bunch of numbers. They are very important. We cannot discard it, but maybe we can move it to the something back at the end, near the end. And for the neighborhood overview, the reason that we might want to move it to somewhere near the end, or maybe even discard it for not showing it, is because the information here is very sparse. There are other ways to deal with sparse data, but if you are showing things that contains little information, it is going to cost your very precious space in your screen. So it would be better to sort of hide the columns that contains very little information. So that's just some rules that I usually to select which columns I should fill and which column is more important. After we choose the columns that we wish to look, so for example, let's say we only want to look at 2 things, a host ID and a host name for these listings. If we want to check who owns these listings, we can use a technique that is very similar to NumPy's ND array. That is the skill, that is the operator called the fancy indexing. Within this square brackets, we can put a list or more complex elements, not just numbers or slices. That is what the definition of what the fancy indexing is. So in this case, we put a list inside the square brackets. It behaves pretty similar to NumPy and the array, meaning I can select columns to view. But just in this case, because the column has a name that is in string, so instead of putting some numbers, we put in the string that is the column name inside the list. There's one difference between the fancy indexing of taking a list as argument for NumPy array is that this is for column, not for rows. This is something need to be very mindful because it is differs from NumPy's logic, despite the many similarity between or analogy between NumPy array and the Pandas data frame. If you are not using fancy indexing, just a regular indexing, you can ignore this and just put the string host ID inside the square brackets, and you can access to the column of host ID. So if you put a single string inside this square brackets as an index, you get a series. That is the column which has a type series. But if you put a list in here, you are getting a data frame because it has multiple columns. Another way to select columns and rows is to use the .loc. In the .loc method attribute here, the first element is corresponded to the index or to select the rows, and the second one is for the columns, for selecting columns. So the order is more similar to NumPy. And again, these numbers and these strings or labels are referred to the labels in the index or in the column. So if you select rows from 100 to 110 in here, it refers to the rows with corresponding columns. But this index is not necessary to be numbers start from 0, like 0, 1, 2, 3, 4, 5, or like the index in NumPy. It can be arbitrary. It could be a string, or it could be numbers, but they don't have to be in the ascending order. It can be anything. So that's the difference between the Pandas data frame indexing and the NumPy indexing. If you want to use the numbering indexing instead of the naming indexing, you can use a method, you use the .iloc. It's sort of like the LOC, but instead it works on the number indexing. So it is called ILOC. So you can see that although it is 100, the same 100 to 110, the semantic is that we don't care about what the label is. We just pick the rows at the number 100 and the rows at the number to the rows at number 110. The similar to the column. Instead of giving the column name, we give the column number like 5, 6, 7. We don't see a 7 here because it's truncated right here. So the difference between I and log is that one is taking the name, label name, and the other is taking the number. So both of the ILOC and the LOC are very useful but in different situations. Sometimes if you are trying to use ILOC, in some case you might also consider by converting the values into a NumPy array. In data frame, it has a very efficient way to convert the content into a NumPy array, especially when the D types are all the same for every column. Now let's move on to some questions related to host ID and host name. For example, we might want to ask who has the most listings, because one host can have multiple listings. A single host can list many different properties. This leads to some additional questions. Can we just rely on the host name to determine if they are the same person, or do we need to use the host ID? Could it be that the host ID and the host name should both be used? For example, maybe one host ID might have a different host name. Should we treat them as the same person if the host ID is the same, even if the name is different? Or is this something we don't need to worry about? These questions could lead to more issues to consider. For now, let's try to use both host ID and host name to identify them. If either of these is different, we will consider them as different entities for now, and we will explore whether the host ID alone is enough later. So how can we do this? First, we simply need to count how many times each combination, the host ID and the host name, appears. We're using the value count method. We'll get a table where each row represents a host ID and a host name, and the value next to it shows how many times it appears in the listing. This essentially tells us how many listings each host has. We might find that the host with the most listings has a name like KYO here. It has 98 listings. And also the host who has a name and an Airbnb and an ID, this one has 71. and so on. You can see the Week4 has, with this ID, it has 60 listings on the data frame. Already we have seen that there are two hosts has the same name. They both name house, although they have a different host ID. So at this point, we already answered part of the questions. Yes, it is possible to have different host ID with the same host name. This tells us that rely on the host name alone isn't reliable, because many people have the same name. Additionally, value count doesn't automatically sort the result, so we have to use the sort values to sort by the count. Since we only have one column, which means it's just series, we can sort it by ascending or descending order, but we don't need to specify which column we are going to use to sort the value. So because we are setting ascending to false, so we sort the values from highest to the lowest. Then we use a head to see the first few samples. Let me also briefly explain the code style right here. We write the code, you can see that we are using parentheses, and we are using a style called method chaining. This is a style of programming where you apply multiple methods to an object in sequence. You start with an object and then you keep calling methods one after another using dot method, and creating a kind of pipeline. This technique is referred to as the method chaining because it links multiple methods together. Some programming language like shell script or maybe other functional language have their dedicated symbols for piping operations. So in shell script, it usually uses the pipe symbol, the vertical line, to pass. So the semantic is that we pass from the data from one operation to the next one to forming a pipeline. So in functional programming language like F# or other similar language in the family, they also have something similar. In an object-oriented programming language, however, a common way to write this style code is using method chaining here. This is a practice for doing things when we want to mimic the behavior of pipeline. So each of the methods will return an object of the same type in most of the time. Sometimes it will return different type of object. Maybe you start with a data frame and then it will return a series. But in general, it's sort of like returning an object at the end of this method. Because the return type is also an object, so you can keep doing the method calling. So that's called the method chaining. So in our case, we have a data frame here. And after running a method value counts, then we do sort values, and then we do a head. We chain these three different operations together. So many developers, myself included, like this method chaining approach because it keeps the code cleaner and more readable. For example, in Pandas, you could filter, sort, or select columns in just one line of code by chaining method. However, one thing to keep in mind is that Python is a language which has significant white space. So Python's indentation rules requires careful attention, and so you cannot freely chaining method across line without properly handling, like the language C++, Java. So if you don't enclose the chain method inside the parentheses, Python will treat them as separate lines of code, and they are not going to chain together. However, by using the parentheses right here and here, you can break this method into different lines, and Python is going to treat them as just one line, as a logic line. So this method chaining approach is common in Pandas and is useful when you want to apply multiple operators to data frame. For instance, in our case, we might want to do things like we do right here. And sometimes you even want to assign and replace the values in some of the columns. And Pandas provides some methods allow you to do things. Otherwise, the things that otherwise you need to have equal sign, the assignment operator. But even for assignment operation, you can use the method chaining with the Pandas data frame. So in some language, you don't need the parentheses right here. But in Python, because it's designed that it with the indentations, so you have to have this one. It may look a little bit strange and sort of look like a workaround, but it has already become a convention, and people do know what it means. So it becomes from a workaround to very popular coding style. Maybe I should not say popular, but it is a very common coding style. Now we want to explore whether there are cases where a single host ID have different names under different listings. So for example, maybe one list might show that the host is James, and maybe he changed his name to Tom and in another listing, but he still have the same hosting ID, and maybe he changed his name to Sarah in yet another item. So if this is the case, then our previous approach of using host ID and host name together to differentiate the individual could lead to treating the same person as multiple people simply because they changed their name. So it is also possible that you might need both host ID and host name together to confirm someone's identity. This could happen in some special case, such as when different platforms merge. So someone or some bigger company acquire a small company and keep the user to have the same ID. So the ID itself may not be enough to identify a user. So you need another columns to make sure they are different person. So we don't know which is the case. They are not equally likely, but there are some possibilities that may happen. So maybe we cannot ever find out because we don't have enough information. But at least we can start to check some of the conditions so that we can at least have some knowledge to rule out some possibilities. So one of the questions is, does single host ID ever appears under different names in this listing? This is a very explicit question that we can ask. If it doesn't, then we don't have to worry about many of the problems. To check this, we can use the NUnique actually, to see how many different host ID exist in the in a data frame. So if this number is the same as the unique numbers of host ID and host name pair, then we are pretty sure that every host ID must have just only one name. Another useful function we can use is the drop duplicate. So we can drop as the name suggests. If we really want to check whether any host ID has been associated with multiple names, we can start by listing all unique combination of host ID and host names. So we can use this one to do that. Another more unique. So by using this unique host, we can check the question more literally. So in this code, we first group by these things by using a host ID. The group by means we separate this data frame into several chunks. So each chunks, they all share the same host ID. So suppose one host ID has a different names. This sub data frame will have more than one rows. But if each sub data frame has only one row, then we know that every host ID can associate with only one name. So this thing is literally says, okay, for each of the different host ID, we check how many names it has. And by using the reset index, we are moving some index to make them as column. Then we can use this one to check, okay, is there any host ID that has different names? And in fact, we find out, okay, we don't need to worry about every host ID has only one name. Another question we might want to explore, although we already have a sense of the answer, is whether different host ID share same host name. So in other words, are there multiple hosts, distinct hosts with the same name? They have different ID, but they share the same name. To check this, we first need to extract a unique combination of host ID and host name. So we use the drop duplicate again, so we can ensure we only have a unique pairs of host ID and host name, meaning each combination appears only once. Next, we use the value counts to see, okay, and apply it to the host name. So in this code, we can check which host name is how many times each of the host name appears in a series. And we see that the James seems to be the most popular name among the hosts, followed by Eric and Amy, and then Jack. Next, we can ask a follow-up questions. Who exactly are these guys who has the name James? So once we list them out, it becomes easier to check things like, okay, are they really a different people or just one people who named James, but somehow he forget his password, so he registered one more account, or he just simply try to register several different accounts for whatever reasons. So if we list these guys, maybe you can check their photo, because we can go back to find the photo URL and to download their photo. If they look the same, they probably are the same guy. So we can dig it and dive deeper into the data frame. But how do we do that? First, we need to filter out the data and extract all the rows where the host name is James. We already know the James appears the most frequently, so we can use this information to find the most frequent name. In this case, it's James. We can use a method called the ID max. It works similarly to NumPy's argmax and helps us to find the IDX that of the most frequent username. It's just because in Pandas, it doesn't call the argument, it called the index. So the name is become IDX max, but they have the similar semantics. So once we have the host name, we can use a method called the query. Query is a very powerful tool for Pandas data frame. The query can let you write expressions to filter out the data in a data frame. If you're using it, it is quite efficient because it allows you to perform multiple operations in a single expression, reducing the back and forth interactions between Python and the Pandas data frame. So one downside of query is because this expression is a string. So you need to be very careful about the syntax. The ID cannot help you much. Although it is possible that in some IDs, it will recognize the Pandas, it will respect Pandas, and knowing that query, the string inside the query is something actually a code, so it will give it some highlight. It is theoretically possible, but I don't think many of the IDs support that. So you still need to be quite careful about the syntax because you don't have the help of the ID. So you are almost on your own. You have to make sure you don't have any typo. One thing to know about is that you see the host name here is the column name, but we don't need a dot or anything. Every variable in this expression is referred to the column name. The syntax is very similar to Python, except that because we are working with data frame, so with data frame column name as the variable name in this expression. And if we wish to use a variable in the Python, like here, most popular host name, we need to put a symbol in the beginning to make some difference so that we can know that this one is a Python variable. There are so many things we can explore. For instance, let's look at an example. So where are these hosts located? We can ask whether all the hosts are based in Taipei, or maybe some of them are living or located elsewhere. By simply calculate some statistic for listing, we can see that the large portion, around like 1800 listings, are in Taipei. And in fact, 792 hosts are just in Taiwan. We don't know, maybe they are in Taipei too, but they just say they are in Taiwan. And in total, there are 77 lists are actually 717 lists are in Taipei, Taiwan. So they are just different writing, but for the Taipei city, so you can see things. But some interesting fact you can find out that is some of the hosts are located abroad, like in Hong Kong, like in Singapore or Vancouver, Canada, or maybe in Los Angeles, CA, California. However, note that we are actually counting the numbers of listings. So although we are not counting the number of hosts. So if a host has multiple listings, each listing is counted. So if you have a host who lists like 5 different properties, they will be counted as 5 times right here. If you want to count unique hosts, like we did earlier with host ID, you would need to remove duplicates by dropping a repeated host ID. And the situation is very similar to what we see in the host ID and the host name, because a single host might has different locations in different items of listings. Maybe he just moved from Taipei to Los Angeles. We don't know that yet, so you have to check it. So this would make things more complicated when you're trying to analyze their location data. And in general, when you analyze data, it is always less complicated. So as we have seen before, you often need to be very, very careful with data and double check, especially when working with information that you get from the web. In this case, we are getting it from web, and we are not doing the data preparation ourselves because there's nothing we can fully trust. If you just even miss some of the small details, it could affect the analysis result later on. I'll leave this as an exercise to you, and so that you can count the number for the location statistics against the host, each host, not against the listing. Also note that we can perform some basic operation on columns by using Python, regular Python things. So this is a very common process because column name can be often related to the data it represents. For example, in this case, we want to find the columns for the review scores. And in this case, all these review scores will start with the prefix review score. So we simply want to check out all the columns that starts with reviews score. So we treat this listing that kind of like a list. It is not a list. It has a special type in a Python type, but it can be iterated. So we run a for loop on it and check every single one element in it, whether it starts with a review score. So we get the columns that are related to review score, and we store it in a list so that we can access them in the data frame. So by getting these review columns, we can apply the analysis method we mentioned earlier using the fancy indexing here to only list these columns. Now we are using the describe method of a data frame to see some basic statistical results. It is very customizable, but by default, it outputs some common statistics as here. For example, we can see that the review store ratings, the count here, it has 4,600 or 4,600 entries. Other review scores has less numbers, so they don't have the equal numbers. This seems reasonable because this one seems to be the primary rating. So some people may be just a little bit lazy and doesn't want to fill out in the detail, but just give an overall rating score. So we can also see that the average score here is about 4.7. It's quite high because considering the highest possible is just 5. And we can see it right here. The maxima of all the rating score is 5 and the minima is 5. Minima is just 1 star. So the lowest score possible here, at least from the data we see, it's just 1. The interesting part is that we can see that for the 75 percentiles, we still got a almost perfect score like 4.95, which is very, very high. And even if you are only at the 25 percentile, you get a 4.6 score, which is still more close to 5 than 4. And the 50 percentile, it means the median, which means about 50% of the score given to a review is more than 4.8. And the other half is less to or equal to 4.8. So from this, we can gather the basic information about the list columns. And we should see more details about these review columns a little bit. So one way we can do is to visualize, to display the result so that we can see the data in a more intuitive way. So you can see that for most rating, it's sort of around 5, coincident to the described result we just in the last slide. In here, we use the matplotlib to plot the histogram. So although Pandas can also create a visualization for many common plots, including histograms, I use matplotlib to get more control over the layout and the appearance of the chart. For example, in this case, I want to ensure the bars in the histograms are aligned to each other, not overlapping. So I'm using matplotlib to do so. There are many other methods that we can do to improve the visualization. So in here, I'm using KDE, kernel density estimation. So the previous bar chart wasn't very effective for comparing different rating metrics. or trends, especially for the things like score that above 4.8. So a KD plot is better for showing the density in a more continuous way. So the curve represents the data's distribution. So we will use the KD and the code is right here, and we can see it is more like here. So just as we say that although Pandas does provide a lot of many plotting functionalities, and in sometimes they are very convenient, but my opinion is don't even bother to learn those methods. You just use matplotlib. It's not that inconvenient. You just have one or more two lines, but you have more control, and you don't need to worry about which plotting method is supported by the data frame. So this curve shows that seems people are willing to give very high score. So the peak is for every sub ratings, the peak is very close to the perfect score, 5-star. But people might be a little bit afraid to give the actual perfect score. So it dropped a little bit when it reached 5, but they are still willing to give a almost perfect score. They are feeling more comfortable to give something like 4.9 than given it by 4 as a 5 points. Okay, next, I originally planned to examine the relationship between the latitude and longitude and the price, and I'm going to do so later on. However, I will go small off-road here. I will explain why in a moment. First, let's see how to I wish to visualize the relationship between the location, geographic location, and the price. So maybe I can see when I do a plotting, I can see most of properties might be concentrated in a more center of the city, or at least in some specific areas, which may be coincident to our general concept of the high price areas. So my first step is here to run the describe method. However, I see something that is a little bit strange because I don't see the price here. Although I give the latitude, longitude, price and put them together to see a describe, I only see a latitude and longitude. The coordinate here, the latitude and longitude, seems to be fine. At least it doesn't have some strange values like -1 or maybe 0 or something really huge like 1000 or things like that. So it seems to be pretty normal, no matter the max. The latitude is also coincident to my knowledge of the latitude of Taiwan. So everything seems pretty okay. The only thing is that we are missing the price column. So why is that happening? So let's take a look at the price data using the head and see a few of the items. So we can see that there are some of NaN values, which is actually okay. However, the main issue seems here to be that the price comma is treated as an object. It is not a string. It is not like a datetime or other things. It should be a number. I can accept it to be a floating number or maybe an integer number. All of them is fine, but it cannot be just an object because it is an object. So that's why the describe doesn't work on the price column. But the question comes next is why is the price has an object as a dtype? So why does it has been interpreted as a string instead of numerical data? This is likely due to the presence of the currency symbol at the beginning of each of the strings. So it is treated like a string because the $sign here. Well, there are some commas here, and but commas may not be a big issue. I think a lot of string to number function support the comma, and some of them may even support the $sign, the currency sign here. But anyway, the fact is when we read from the CSV, this column is treated as a string. The approach here we are using is a simple one. We apply a regular expression to remove the currency symbols, commas, leaving only the numerical parts of the data, and then convert it to a floating number. However, this method has a couple of issues. So first of all, we can't be sure that every entry in a column is indeed a price with a currency symbol and a comma. We should actually verify this assumption to avoid some problems later on. If we don't check it, this could cause a bigger issue in the later analysis. So in fact, we were going to encounter some strange problems, which I'm not sure the reason, so it still has a possibility related to this approach. Another issue is this line is not very readable. Not only this is not reliable for the first issue, it is not very readable. So even if this thing is correct, we probably should have a function, define a function, or even better, using a function from the library, or maybe even from the standard library to do that. So I believe that when we read the CSV, we can give some options to handle this type of currency numbers. But one thing is, before we load the CSV, we cannot know these issues. So unless we go back time and give the options, we have to start somewhere. So the first time we load the CSV, we must have these issues. And because this notebook serves as kind of like a journal for how we do the exploration. So it makes sense that we find out a problem and we go back and load the data again. So that's one way to do that. But I don't want to do this right now because we have already worked on the data for quite a while. So maybe I just want to replace the column with the correct values. But even in this restriction, we probably can find a better function to do the job instead of using an ad hoc regular expression. So the lesson learned that in the future, I probably should check it at an early stage and find this issue even earlier and check it more careful. But for now, let's just proceed. So after converting the price column to numerical format, we notice that something unusual value. There are some unusual values. For instance, the maximum price is 800,000, which is quite high for a single room rent. It is possible that someone set an artificially high price because they didn't want to rent out the property. This could explain the high price. On the other hand, the low price is we only have $4 for the minimum price, which is even more puzzling. The 25th, 15th, and 75th percentiles looks reasonable, but this outlier price, 800,000 and $4, is more alarming. So they might screen the data and make our result unreliable. So we will have to decide how to handle these extreme values, as they may distort the analysis. And in fact, we are not entirely sure they're mistake. It is possible they are just one room that is so expensive that it requires like 800,000 for just one day rental. So we need to make sure, we need to dive it a little bit deeper before we do the conclusion. So to investigate further, we can use a method called the largest to list the highest price items. When we do this, you can see the 800 price stick out. It doesn't seem to have any reason to being that high. There are also other high prices items like 320,000. You can see like this one, and almost 280,000 and 250,000. And I have already checked review ratings. The top like 1, 2, 3, the top 4 items does not have any review ratings, except the 5th one, this one, has a 5-star review. So maybe this one is legitimate. After all, it is in the Xinyi district, Taipei, which is probably the most expensive area in Taipei, and it is a private room. So we probably still need more time to spend more time to investigate why certain listing has such unusual high price. It is unclear whether to remove these listings or keep them. But for now, we have identified that at least we know that there are some items have some unusual high price for renting. So we need to be careful about this. And next, we will take a look at the lowest price listings, and they are even stranger. Some prices are as low as 4 or 5, which raises a question. One possible explanation of this is these low values actually represent ratings rather than price. Or perhaps these prices are listed in a different currency like US dollar, whereas most of the dataset seems to be in Taiwanese dollar. For example, seeing price of 3,000 wouldn't be too unusual if it is in the New Taiwan dollars, but if it is in US dollars, it would be unlikely high. We suspect that this extremely low price might have been entered incorrectly or extracted incorrectly when they scraping the web. It's also possible that these listings are just a placeholder for our mistake in the dataset. This analysis suggests that we may need to apply a stricter check, a more strict restrict check or clean procedure for the price data because the outliers are not reliable. So our first hypothesis is that these extreme low values might not actually be price but rating scores. They could be errors that slip through. For instance, some of these entries might have prices listed as less than 5, which seems unrealistic. To address this, we can discard any listings where the price below 5. Similarly, we might consider removing any listings with price between 10 to 100 to avoid outlier. But we want to sort of find some evidence to support our hypothesis. So the first step, I want to check is there any price values between 10 to 100. If there are none of listings has a price between 10 to 100, then it might suggest that okay, the 4-5 anything below like 300 is belowing like less equal to or below 5. Then it might suggest our hypothesis has some evidence these things are actually the misplaced reviewing score. But if there exists something between 10 to 100, say like 70, 71, 77, things like that, then the hypothesis of the rating score alone cannot explain all, at least cannot explain all the low price. So we use a query again to list price above $10 and below $100. And we see there do have some entries satisfy this condition. So our hypothesis may not be good enough. And even worse, we find some very strange price like 81 and 91. If the price is something like 99 NT dollars, I probably can imagine that okay, they want to have a low price to attract people. But for price, if it is in Taiwan dollar, for a price like 91, it doesn't seem like a usual price that is listed in Taiwan. But perhaps maybe there's some other explanation. Maybe it is like a $3 because it is listed as 3. It is converted into the currency of Taiwan. Maybe, but we are not sure. And this seems to be a little bit more complicated than we expected. So we probably just leave it here. But when we doing the statistics or any numerical analysis, we have to take this situation in mind to avoid the outlier, or maybe just consider there are some outliers to make our computation and studies more reliable and robust. So now we have identified these anomalies. So let's try to do something with our price data for further analysis. So this is just one of the things we want to explore. For example, we want to investigate whether different types of properties, such as different room types, have varying price range. Because of our earlier experience with extremely high low price, we'll start by filtering out listings with price over 30,000 and below 300. This will help prevent these outliers from skewing the result. Our goal is not to focus on the highest or lower price, but instead to understand the general trends or distribution by looking something like a median, mean, or 25th, 35th, 75th percentile. So by removing the extreme data, we can focus on more reliable data. We classify the listing by room and the properties. So we use a group by room type and the properties to separate this big data frame into small data frames. Each of the small data frames has the same room type and the property type. and we can do some operation. In this case, we do the describe. And also, we'll limit our analysis to room types that has more than 30 listings. This threshold will help to ensure that we are only looking at room types that with enough data to provide meaningful insights, especially because we know there are some unusual outliers. So suppose we have a category that is too small, and if there is like just one single item in this category is an outlier, and not only just it is outlier, it has a error, the number in that is not correct, it will affect the result a lot, especially for the mean, or maybe like the 75 percentile and the 25% or median. It will affect them a lot. But by restricting our condition to only for the category has more than 30 listings, the result should be more reliable. So let's sort the result by the mean price. So you can see it kind of makes sense to see this result. So the most expensive room type seems to be the entire home apartment, and the most expensive one is with the property type entire home. And for the share room, it's getting cheaper. So everything seems to be okay and seems to be normal. And we have this result. Maybe you can do some visualization with this result and see more things. Next, we'll return to the topics for do the plotting of the price and the geographic locations. I'll first show the chart to give you an idea what I am aiming for. This is arranged according to different price level. So creating the heat map in this scale. I took a logarithm on the price, so you can see that it is actually a logarithm of the logarithm of the price. Because many times it makes more sense with a logarithm scale. So for example, in our case, it seems like 100,000 and 10,000 are quite different, and the level of the differences is comparable to the difference between 10,000 and 1,000. And also, in a case that say 100,000, the difference between 100,000 and 99,000 is kind of small. They only differ by 1,000. However, if we consider a price of like 1,200 and the other one is 200, the difference is also 1,000. But 1,200 seems to be a lot more expensive than an item that only costs $200. So this observation suggests that maybe the logarithm scale is better suited in our situation. So we'll give it a try here and do the logarithm scale. So this scatter plot are plot according to the geographic location. So the x-axis is longitude and the y-axis is latitude. You can see that the shape of it roughly resembles the shape of Taipei, and the brightness of different part of areas also makes a little bit, seems to make some sense. Like most of them are centered near the center of Taipei city. So here is how we did it. First of all, we dropped some NA values because there are some NA values, not available values, none in the price. And in order to do the graph, we dropped the NA value. The drop NA is also used a lot when people cleaning the dataset. Based on the previous experience, we wanted to filter out the extremely low or extremely high prices. So we only keep the price greater than 10 and less than 30,000. You can set the threshold to a different values, but we are using this setting right here. And finally, I simply plot the scatter plot using the latitude and longitude as x and y coordinate. I put the latitude and longitude directly from the data, and I used log for the prices. We apply the logarithm to the prices here. So you can see that comparing to directly using the plotting method in the Pandas data frame, we need to write things a little bit longer because we have to write the data frame 1, 2, 3 times. So that's the small convenient we have to pay. But in exchange, we have more control to the plot, so we can get what we want. I'm changing a CMap and changing alpha and getting different aspects of the plot figures and different resolution of the figures. But this seems to be a little below our expectations because we also want to have a Taipei city map as a background of our plot. So here we can do that easily. We're using another plotting library called the Plotly. Okay, let me go back. So we are using another library called the Plotly. You can see that here refer to the Plotly Express, which is a higher dimension, higher level interface in Plotly. Plotly has a lower level API and a higher level API. This one is a higher level one. And it is more interactive. I personally really like Dash, which is also from Plotly and is used to create simple visualization of web apps. So the full name of it is called the Plotly Dash. So it has a very good integration between Plotly Graph Library and the Plotly Dash web app framework. So a lot of functions, we can use a lot of different Plotly functions. They work greatly with the Plotly Dash. So here I'm using the scatter map box instead of just the vanilla scatter. And I'm using a map box style called the OpenStreetMap. There are many different map box styles available for this function. I'm choosing a style that does not require some API key. Other than that, things are pretty similar to Plotly version. And we can see a result right here. So it is very interactive. And when I do the mouse hovering, it will show information. And I can zoom in or pan the map. And of course, there is a Taipei street map. And we can check the points and their locations without guessing. I want to give another remark, that is, when we do the visualization, it is not just simply for a show. It is actually a pretty good way to do the debugging or to explore the data, to see the content of data. So for example, when we just see the longitude or longitude, we use it to describe and see the numbers. We cannot actually sure these points, in fact, there's no anomaly in it, because maybe they are in a range, but these locations may be in the New Taipei City or maybe other part of Taiwan or maybe on the ocean. But by doing the visualization, we can make sure everything is as expected. And more things, like we can see that a lot of the dots seems to be at the place that is pretty crowded in Taipei, and they sort of align to the string or the boundary of the neighborhood. You can see that it's very like here is very clear. It is located in that polygon. So that makes us believe that everything seems to be correct. So the data seems to be normal, and we don't need to worry too much about the longitude and longitude. And I made another plot that is using the similar technique as before, using a KDE or like a Gaussian kernel things, so that we can see a more continuous distribution instead of just dots. So this looks more like a heat map, and we can have a better visualization of which part of Taipei is more expensive or more crowded for renting. Now we are going to load the calendar data and try to work this calendar data with the listings. So first of all, let's list the columns right here. The first thing we observe is that the price column seems to have the same issues as before. So we're going to do the same regular expression way to fix this column. And secondly, let's see the D types here. There's another D types that is less than perfect, is that the available things should be a true false value. You can see that F here and maybe some T, you will see that there is some T there. So it should have a Boolean data type instead of just string. So that may be something we need to check about. So we are going to do a merge, which is going to combine the information from the listing to the calendar. So we'll handle the D type, like Boolean D type and maybe price a little bit later. But first of all, we are going to merge the data to extract data from the listing to get into the calendar data frame. But first thing we observe that there are some conflict in the column name. One is that the price column. There's a price column in the calendar, and there's also a price column in the listing price. Although it will change the column name automatically when you merge them if there are some column that has the same name. But we want to make things more predictable. So we rename the price column in the listings, the listing price. So next we will performing the actual merge operation. So this we are calling a merge method on the calendar data frame. There are similar operations such as join and merge. It works primarily for the similar things. While merge is more focusing on merging columns by columns. However, join is more working on combining two data frames by their index. But essentially they are pretty similar and related to the similar concept. So in this case, we are using merge. You can see that in the listing table, we only use 3 columns, ID, name, and the listing price, because we are only interested in the name so that we can replace ID for readability, and we'll compare the price. So just using these 3 fields will be not enough for now. So we won't put too many columns in here. We'll merge the calendar data, which already contains the information. The result of the merge will always create a new data frame. It is more like kind of related to a SQL or relational algebra and the same join concept. So in the relational algebra, there are many different types of join, like inner join, outer join, natural join, and so on. We'll be using the left join here. What does it mean? It means we will return all the rows from the left table. In this case, the calendar. This one is left one and this one is right one. So we are pulling the rows and combining the information to every row of a calendar. So you can see that in this merge we have several parameters. There's a left arm and the right arm. The left arm refers to a column in the calendar data frame, and the right arm refers to a column in the listings, that is right data frame. So the thing goes like this one. For each row of the calendar, we're finding the ID right here, the listing ID right here. For each row of the calendar, it has a different column. It has actually 7 columns. We are trying to find the listing ID and get the number here. Then we look up the table, look at values in listings. We try to find a row that the ID in this, the row that has an ID similar to the value that, not equal to the value of the listed ID that we just pulled from the calendar. And we can get the information from that row. In this case, we only get the information of ID, which we already know, and the name and the listing price. And we contrast 3 new columns in the calendar data frame. That is ID, name, and the listing price. And we'll fill in the values by the process we just described. And we can fill in the value in these 3 new columns for each different row. So there are some edge cases that what if we can find more than 1 rows that satisfy the condition? Like what if many of the different rows have the same ID in the listings? That will make things a little bit difficult. So that's the difference between something like natural or other different join. So that's why we have a lot of different join methods. But in this case, we don't need to worry about it because every ID appears only once in the listing data frame. So we simply do something like a lookup table. The key of the table is ID, and we using the listing ID to query the listings by finding the same IDs here. And we get the ID, get a name, and get the listing value, and to fill in the values in the newly constructed columns, which have the same names right here. So it looks like the merge table looks like this one. We have a listing ID, date. All of these things are from the original calendar data frame. And we construct 3 new columns, name, price, and ID. I manually remove the column ID because it is duplicated with the listing ID. They are always the same. Otherwise, you cannot match them. So we don't need 1 more duplicate column, so I remove that. But we still get the name and the listing price. So we immediately actually noticed that the listing price and the calendar price is not the same. It is 34 and it is 1,107. So why is this happening? What caused these differences? It might be this is in the currency of USD and this one is in TWD. The number seems to be about right, but we may want to check it for sure. So we do a simple plot to see whether is that true. But we still see that most of the price and listing price and the calendar price are on the diagonal line that indicate they have the same value. But it is not a very clear and very accurate line. It is just have some trending, has some correlations. So maybe the currency is moving. No, we don't have currency because they are the same value. So I'm not sure why this is happening. This is also requires some more deep dive into the data and to see what happened. And we do see some very outlier. These outliers may help us to further filter out some items that is not reliable or mistaken. So next we want to perform some basic statistics on the price. Since we are aiming to set up examples that we're going to introduce the pivot concept. So currently now we are going to start by creating a simpler table to work with. What I mean simpler is that currently the table contains a lot of different dates. There are just two main dates like 365 dates. This makes the table a little bit bigger. We want to have this time point. So I'm going to average the price for each month. It turns out the time span is across like 13 months because it starts from June and end to June of next year. So it contains actually 13 months. So how do we do to find the average of each month? So first of all, we create a new column that indicates to the year months of that date in the calendar. We use the method called the dt to period, and the m stands for the months. So we can find the months corresponding to the year, corresponding to the date in that row. Then we should do something like a group by and on this column. And then we do the group by. So we simply do the group by for each listing ID and each year month. Then we do the average, the mean for the price, and we simply reset the index to make it a little bit prettier. So you can see, okay, so this is the result. For each ID, we have 13 months corresponding to this ID, and we have a column for price. This is computed by finding the average price in the corresponding months. So this one is for the first listing ID, and this one is for the second listing ID, and this one is for the 13th ID, and so on. I just cut the table to make it easier to visualize, to see the values here. However, it seems like that the price is not changed, it's just constant. This is not good for us if we wish to make it as an example, because it's going to be too boring. So we want to check if this is actually happening. So I'm going to compute the standard deviation for each of the listings. So if the standard deviation is 0, it means the price is not changing. I'm using the same way to do that, doing a group by listing and apply it on the price to compute the standard deviation. So pretty much the same. And in fact, it does show that the price of each listing is just a constant. So so we have to change to another target that is more interesting. So we are trying to do it for availability. But instead of doing availability, we are working more aiming on the unavailability. So about the ratio of days that is not available instead of available. But before we do that, we have to handle the data type here, because currently the calendar available column has a data type of object, and which indicates it is a string. And we can see that it seems like the F stands for false and T stands for true. But because it is string, it's no way we can sure that every single item is either T or either F. So we have to check it. We use this to check that every element in the calendar is in. This is also a method of data frame. Actually for this series, because we take this one element out. So this one is a series. We check that every element in this series, whether it is in this list, and use the .all things to check everything is true. So in fact, it is true because we have passed this assertion checking. And then we do the value counts to see how many values are false and how many values are true. So they are roughly equal. They are more false than more true, but they are kind of roughly equal. So we have already checked that everything is either T or either F, and we want to change it into the Boolean type. So we use, because we have already checked the assumption that every element is either T or F, so we simply can check whether it is equal to T or not to convert this value into true or false as we wish. And we have done this, and the D type is already been Boolean. Okay, so as we probably mentioned before, we want to check the ratio of the date that is not available. So of course, when the room is occupied, it is not available, but we are not sure it is the only reason. Maybe it's just the host want to have a vacation, doesn't want to handle the management, or maybe just he don't feel like to rent their house in the summer, or maybe just for other reason. So not available doesn't mean occupied, but we can think if it is not available, maybe it is occupied. So maybe the host make more rental and get more monies maybe. So we want to calculate the proportion of days that each listing is marked as not available. And hopefully this values is not constant. And before that, we also have something need to check. We should check that every listing has 13 months, and each month has enough day, have every day that is supposed to be in that month. So a lot of check-ins can be happen right here, and we should do that. But I'm going to skip this part because we have already done a lot of things like this one. We're going to move to the more interesting part, that is a pivot, table pivot. So again, we are using group, and we are going to use two methods to do the same, to achieve the same result table that we wish to have. The first way we are using is a little bit slower, but it is easier to write, especially for beginner. So we are grouped by listing ID and the year month and getting available. So we are getting a lot of series, small series from available series, and each of the small series has the same listing ID and the year month. Then we can use apply here to convert this one, to compute the values here. Because we only want to find date that is not available. So we get x is equal to false, and we compute the mean. So we get a ratio here. And by reset the index, we are going to get and change the name of this column. And also because the index was originally should be listing ID and year month. By using this reset index, we are making these two to be columns. This one works. If you can write code in Python, you can do any function on the group by object. However, this one is slower because it is calling a Python function. So it takes like 4 seconds to run. Another way to do that is using more like element-wise operators. Software like what we do for NumPy. So we actually compute the available ratio first, then we use 1 minus it to get the not available ratio. So this one only runs like 0.5 seconds or less. So here is the result. Okay, so we kind of still like getting a listing ID and the different 13 months. And each one we got a not available ratio here. And here is for the second listing ID, and it's 13 different months, and we get the not available ratios. So we will have an idea of what the tables we are having right now. And in the next session, we are going to apply a pivot on this data, and you will see what happens. So here is a pivot table. So this is our main objective in this part, which is calculate the not available ratio for the, and using that table to do a pivot demonstration. What we are trying to do here is, you can see that in this table, it takes a lot of space because for this listing ID right here, it repeats a lot of 13 times for almost no reasons. And for each of this block, this year months repeat again and again and again. So it seems to be a little bit inefficient. Moreover, it is difficult for us to using this data as a training data because we cannot even easily shuffle the data. When we want to take the, suppose we are trying to find the sequence of availability in this year and for this ID, we probably want these things to be put together. So when we shuffle, these things they have be coupled together. But because in this format, each row, I mean, the data is separated into 13 different rows. So if we shuffle data, they are going to be split up and to be appeared in different places. It's very difficult to access this data. So maybe we can make things a little bit different by reshaping this data. So that's why we are going to use the pivot. The pivot, we are telling it like, okay, let's have the index to be the listing ID. So we have a lot of different ID, but each row contains only one ID. And for columns, we have year months. So we have 13 columns, each corresponding to the different year months. And in the cells, we have values. And of course, the values is the not available ratio corresponding to the year months that has one over the column and the listing ID of the row. So that's it. That is the pivot method and the information we need to provide to this pivot method. And you can see that the above is the transform and the result data frame. The listing ID is on the index and the year month is as the column name. And we can have, they are not going to repeat anymore. They are just repeated once. And this one, every listing ID is appeared only once. And we can take this one as just one row. So we can, if we shuffle a row, we can easily shuffle everything. And if we want to access the data corresponding to one of the listing ID, we just take this row. We don't need taking like 13 rows and to worry about, oh, this is the starting of this row. I mean, starting of the block of the rows of this listing ID, or maybe it's just in the middle. We don't need to worry about it because after using this format, the pivot format, it is going to be easier to operate and process. Okay, then let's now enlarge the table we were just working with. This seems to be pretty good as we can see. But there's one small issue that we may have a chance to improve. That is, currently the listing ID is not readable. The year date, I mean the year month is pretty human readable. We know that it's 2024 and November. And every number here is a ratio and indicated to the non-availability ratios of this month and for this listing ID. The only thing that doesn't make any sense here is the listing ID. It's just a number. We don't know what it is. It has no information except saying that these things are different. Because the relation between the order, I mean, this one is bigger than this one. It doesn't have many meanings. So can we replace these IDs with more readable names at least? Okay, so next one we can do that. Here we demonstrate how to replace the ID with something more readable by using the information we have already merged into the calendar. That is the listing, the name of the listing. We can use the rename right here. So previously we see that we're using rename to rename the column name, to rename the price to become the listing price. And here we can also use the rename to rename the index name. So we are renaming it into the listing by using a listing and its name. So we rename everything to a listing ID right here. So that makes everything sort of readable. So you can see that everything directly changed into more readable format. That makes our things more easier to interpret. So after updating the data, we can apply one of the methods, even though we are not actually performing machine learning in this point. One way to use this data is to ensure that each of the listing ID only has one row, so that we can compute the average of each row. Also, after compute the average of each row, we may want to, we're interested to see which listing item is more valuable than others. So we do the simply sort values. So we can see the most unavailable items, and we can see this some apartment and some of others, and we can see that all of this unavailability is almost 100%. So let's do a further investigation on the distribution of this unavailability. So we use a quantile to see the percentile. Instead of just using a describe, we use more detailed control and only see the quantile here. But you can see that this guy is not that readable. So I'm going to show you one more usage of a data frame. So besides the various useful methods and functions provided for data frame, and doing the analysis. One additional advantage is that it can help to format the data to be more readable. So for example, in the previous result here, it is a little bit not human friendly. However, we can convert the result into a data frame and use the many functionalities of a data frame to format the data. So it looks like a table, and we can actually use the data renderer to explore it. Even if we just print it out, it looks more pleasant, and we can set the format easily by using the data frame API. So that is one of another usage of data frame. And of course, we can also use a chart to visualize if that is all we want to see. And we can see that the x-axis is a quantile and the y-axis is a not availability ratio. It seems to be pretty linear, like a straight line. So that wraps up the introduction to the Pandas functionalities and the features. There are still many more functions worth exploring, so I encourage you to play around with it and familiarize yourself with how it can be useful to your specific needs. At the very least, you can try running the notebook we just discussed and develop for the class to get better understanding. Finally, I would like to introduce some more framework and libraries to that is go beyond Pandas. Pandas has been around for quite some time. The different versions have brought various changes. Initially, it was more based on NumPy, but over time, newer tools like PyArrow has been integrated for better performance. As technology evolves, newer or more modern tools are being developed to address various challenges in data processing. Although these tools share the same concept like a data frame series, they may offer more cutting-edge solutions. I've listed a few tools that can be considered as an alternative to the Pandas, but they are not exactly the same. For example, some features like a data renderer may not fully work or even work with these frameworks, but these tools still feel quite similar to Pandas in how you can interact with them. The first tools we are going to talk about is the Dask, which is designed for handling large datasets and parallel processing. It allows for distributed computation on large data, much like working with big data. One aspect of Dask is that it can be used as a large-scale version of Pandas, or Big Pandas as it is referred in the web page of the Dask. So on the right hand side, you can see some simple code, which is quite familiar if you know how to write Pandas code. You see that the command like read parquet, similar to read CSV, but it just read parquet. And you're doing some computation like sum. We haven't covered this before, but it's pretty much like a min, except it computes the sum. And it also has some capability to read the files from S3. The difference is that you can notice that everything here, it has a dot compute. We don't need this similar things in Pandas. This is because Dask is more focusing on a more parallel distributed environment. So you need to explicitly tell it to perform the computation. Unlike in Pandas, we don't need it because we can do the computation immediately. Dask allows a lot of things for parallel handling, for like a large array or maybe for machine learning. So, in some cases, it can also be considered as a more powerful and distributed version, parallel version of NumPy. Another tool is called the Pandas. We have mentioned it a few times, which is written in Rust and is similar to Pandas in terms of working with data frame. Pandas is known for being more modern and is positioned as a potential replacement for Pandas, although it is not a drop-in replacement. One of the selling points is the speed, as it is optimized for performance and because it is written in Rust. Another key feature of Pandas is the ability to perform lazy computation. This means that you can define a sequence of operations without immediately execute them. After defining these steps, you can treat the entire sequence as an object and pass it to other functions or maybe to a function executable, a process written in Rust. And in fact, you can serialize it for later use. This is a flexibility allows you to store, read, and compile the object for fast execution when you are ready to let. And lazy computation enables you to optimize performance to avoiding unnecessary computation until the operation has been defined. You are ready to execute them. This makes Polars particularly powerful when dealing with complex data pipeline or large data set. So here's an example of using Polars. Everything is quite similar to the Pandas, except for the first one. You will notice that it is scan PSV instead of using read CSV. While Polars do have a version called read, it does have read CSV function, and it was similar to Pandas. Scan CSV is the lazy version. So after we using a scan CSV, it returns a lazy data frame, and then we can apply various operations like a filter, group by here, and aggregation here. And this is not going to run immediately. It is becoming to a query plan. So it has a variable name called Q here, because the terminology of calling this sequence of things as a query plan. The query plan won't execute till you run the .collect. So the downside of this lazy approach is that it might not be as flexible during the phase of exploration. So for example, with Pandas, we can explore your data step by step. Like what we do before, we find out, okay, the price column does not have correct data type. Then we can go back and fix it and do things. And we cannot anticipate these things before we even load the data. So we cannot, in principle, construct the plan beforehand, because every step is based on the result and we made a decision after each step. So we cannot foresee what we are going to do. So we don't have a plan yet. But after you have already make mind of what should appear in your data pipeline, then you can switch to scan CSV and chain the operation together just like here. Because the similarity between the lazy data frame and the eager or just regular data frame. So sometimes the change is as easy as simply rename this read CSV to a scan CSV. Then you can get a query plan, and it offers a significant performance improvement. Not every operation can be done in an eager data frame can be done in a lazy data frame. But the Polars is really fast. Even if you don't use the lazy version of this API, you just use the eager version. You simply switching from Pandas to Polars, you will get a significant speed up in a lot of different scenarios. Maybe like 10 to 5 times or even 10 times faster. It's not unusual. So overall, Polars is a highly modern and efficient data frame system. It's worth trying, especially when the performance is a critical factor. The next tools I'm going to introduce is Vaex. It is another popular library, and its main selling point is also speed. In particular, when dealing with very large dataset, it is designed to handle data that exceeds your machine's memory, something that Pandas struggles with due to its memory limitation. Although Pandas offers some chunky method to handle larger dataset, they aren't always very efficient. Vaex, on the other hand, is specially optimized for out-of-memory operation, making it suitable for handling large dataset, where you would typically encounter memory bottleneck. If the dataset exceeds your system memory, you could try using Dask. So here is some list of features of what Vaex has. It is more performance centered. It is can work with huge tabular data. And it also has some lazy and virtual columns that you can work with, and it's very memory efficient. It also comes with some user-friendly API and visualization that may be good to work with. But personally, I didn't use Vaex, so I'm just saying that it is something that people use. So finally, I've also included a simple performance comparison. You can create the link to the source. So this comparison is between DuckDB, Vaex, and Polars. And this is only compare the memory usage. So you can see that the DuckDB has less memory usage, and followed by the Vaex, and Pandas has more memory usage here. And there are also a lot of different comparison benchmark around the web, around the internet you can check. But all these three frameworks are quite efficient comparing to Pandas. And personally, I like Duck, but DuckDB is more like a compatible and alternative to SQLite, sort of like an alternative, but they are aiming for a different type of application. But it is also a local SQL system working with a single file, can work with a single file. But DuckDB is more aiming on the numerical or data analysis part. So it can easily convert its queries into data frame in Pandas or Polars. It can use your data frame as, the Pandas data frame as the source of its database. So you can use DuckDB syntax, actually just a variation of the SQL to query data frame and packify and its native database. But I won't put it as a replacement or alternative to the Pandas because it is more like a SQL database and using it with SQL syntax. It is developing an API more similar to the Pandas things, like you can do the method chaining. But I think the primary and the most common use is still using it kind of like a SQL server or SQL engine, I should say. So that's all for our topics here. I hope the introduction raised your interest into the Pandas framework, and hope that Pandas can be one of the tools that in your toolbox to help you to do the data analysis in the future works.